would like to say the full name because it's Dr. Doris Chen, and she has a PhD in computer engineering. And she's originally from Sun Microsystems before she joined Microsoft, so she has a really nice breadth of the industry. Extremely intelligent woman and fun to listen to.
Thanks, Anne. Okay. You guys could hear me okay?
Yes.
Great. Okay. Let's get started. So, performance talk is always a tough talk, but it's always one of my favorite talk because every time I give a talk, I'm getting feedback, getting questions. I also learn something as well. So today we're going to actually spend some time to talk about how we could build a high-performance website as well as modern apps with JavaScript and HTML5. Anne just did a very good introduction about me, but I just want to leave you a few contact information in case you have more questions or feedback. I usually post my technical content, presentations, all the videos, all the code on my blog. I usually don't remember my blog address anyway, but if you search Doris MSDN, the first link is usually mine. That actually tests on different search engine already, so you could try. My Twitter address is Doris T Chen. There's a T in the middle, so make sure you send to Doris T Chen. Otherwise, I won't be able to receive it. Somebody took Doris Chen. Okay. So my email is doris.chen@microsoft.com. So you probably see something like called office hours. This is sort of like a new program for us. I'm based in Mountain View, Silicon Valley, but what I do is I usually meet developers from time to time. We could set up time from the user all hours. I could meet you in person in Mountain View office, or sometimes I could meet you on Skype if you have some questions on developing apps. So we could chat, and it's totally free. It's Microsoft pay me pretty well, so I don't charge you guys. Okay, so like Anne said, I have been with Microsoft, so this April will be my 4 years. Before that, I spent over 10 years as a Java evangelist at Sun Microsystems, working with Java community many years. And before that, I'm just busy, writing my dissertation, trying to graduate earlier. So I'm actually, my dissertation is really on medical informatics when I was in UCLA. So if people are interested in medical informatics, could talk about that. All right, so I know that you guys couldn't wait to get into the real content. Okay, so we have a pretty busy agenda. We're going to talk about, the most important thing for us to start with is perhaps start with some of the best practice. We still apply for a modern JavaScript application. So we're going to start really briefly on that. And then we're going to use a casual game as an example. We're going to show you how we're going to apply 5 different principles onto that. We're going to go over a lot of code best practice and tips. And we're going to go look into that game and try to make it faster. And if we still have some time, I do want to address another topic, which is we talk about websites. But really, with the Windows 8 apps, the way you try to optimize your website using JavaScript is exactly the same as you will optimize for your apps. The reason is you could use HTML5 JavaScript to develop native apps in Windows Store. And then the engine, JavaScript engine, running in IE 10 above, it's called Chakra, right? Some of you may know. It's the same engine running for the Windows 8 platform. So that's why everything I'm talking about, all the best practice, will apply for all the websites, all the major websites, as well as for Windows 8 app. And then we maybe, if we have time, talk about the startup time, because it's important for any apps. Okay, so let me actually get a little background about you so I know how to pace my talk. I would assume everybody knows JavaScript. Okay, good. How many of you here are game developers? Okay, all right, so very good. So I would assume the rest of the crowd is maybe just developing apps using JavaScript, right? Not necessarily games, right? Okay, how many of you are actually using game engines like Unity, Visual Game Maker, Constructor? Okay, again, very good. Okay, so that's very good because everybody seems like on the same page. So let's actually start with some of the general best practice for JavaScript. A lot of them are peer review for you, but you just remember some of the old kind of tips still working. So in the HTML, very old subject, it's still working pretty fine. For safe dynamic content, it should be good for you to use to create your DOM. Because we all know in order to create a DOM tree, it is a pretty expensive operation. So if you can, you could still leverage in the HTML to do something if you want, right? So it's still a tip would be good for even for modern apps. The rest of them is really from Steve Souders' 13 rules at the beginning. For example, link all your CSS style sheet at the very beginning of the page, not at the bottom. Could anybody tell me why is that? Yeah.
You want to get the first thing that loads?
Exactly. You don't want to have a blank page. You want something, right? CSS will define all those layouts, all the content for you, so you will be able to see something, right? Otherwise, you know, I asked this question a few years ago. I said, what is the people's tolerance these days? Meaning, if you click on something, right? How long are you willing to wait until you give up? Anybody want to get a wild guess?
5 seconds.
5 seconds, very generous. Any other answer?
1 second.
1 second, 2. Okay, so that's actually very close. 5 years ago, when I asked this question, 3 seconds is the national average. 3 seconds, all right? So you have to make your user happy within 3 seconds. However, nowadays, with all the real apps, native apps, we're looking into milliseconds. So it is really quite a bit of challenge for your apps, either games or website, because you talk about modern browsers. We talk about a really quick response and really fun things to work with, not a very static page anymore, right? So CSS, all the performance things, make sure it's on the beginning, you know. But somebody says, you know what? I do have something which may take a little longer than milliseconds, right? A page startup or something like that. Have you heard a term called perceived performance? Some people do, some people, yeah. So a classical example is if you do some download, right? You download an app, you download something, you will see from 0 to 99% from that little progress bar. It's like zoom. But takes the last 1% forever to finish a download. Why is that? This is the same concept as the perceived performance. You want to make your user happy. You want to make your user see this app is very responsive. So, you know, you can wait for 99% of the time. You cannot wait the last 1%, even though it takes quite a while, right? So this is little like a human psychology. Same thing applies to splash screen at the beginning, right? It may take a little while, but if you make your splash screen interesting, people could read, you catch their attention, you're the winner, right? So this is something, it's important, that's why we said leave all your CSS at the beginning. If you need to do a splash screen at the beginning, try to do it. Or if you do some animations or say give people a little puzzle to think about, because that will win you some loading time, isn't it? All right, so do it. Obviously, another best practice is avoid inline JavaScript and CSS, because that's what we call spaghetti code. Especially in nowadays, you have a pretty large scale apps. You don't want to mix everything inline. You want to separate them. JSON is always our best friend. You basically you want to use JSON a lot, and you don't want to use it really by hand. You want to use all the nice utility from JSON. This is really peer review. So for more like those tricks, the tricks and tips, I could look into that talk. It's they provide you 50 performance tricks and tips for you to look into to make your apps run faster. Okay, some of the people says, what is the inner HTML? Just a little review for you, things like that. Document get an element by ID. In the HTML, you could just directly assign your username onto it. It's a very simple way, but you could still use it. It's still very fast. This is something to do with inline JavaScript. You probably don't want to do an inline JavaScript in the header. Why is that? Exactly, it blocks. Because maybe you have a few JavaScript library. If your JavaScript is very big, it will take time to parsing. For any JavaScript engine to parse it, doesn't matter how fast the engine is, it has to parse, right? So it will take some time to parsing. If you leave it at the beginning of your code, then you're not going to see much response on your page, right? This is something you need to keep in mind. But I think this is really applied to Steve Sauter's 13 rules. It's one of the rules. Okay, so some of you may be from an enterprise background. Maybe you're doing some solar, service-oriented programming. But you may have your specific XML data or XML representation. But keep in mind, JSON always a winner. JSON representation is always faster than most XML representation. So even though you have some specific XML data, try to use JSON. This is the representation-wise, it always takes time to parse. So you probably couldn't beat JSON's representation. So that's another tip to share with you. Obviously, using all the JSON library, and do the parse using string file instead of come out with your own method to do that, because you don't need to. The library is already there. It's very fast. Okay, so I guess that's a basic review for you guys, right? Okay, let's move on. So let's take a look at this game. It's a casual game. It's what we call high five kind of game. It's a pretty simple game. And then we're going to actually apply 5 different principles onto this game and to make it run faster. And then obviously performance tuning is a pretty complex subject, right? So when I'm talking about all the principles, all the tips, I'm not really talking about, from beginning you have to look into your app or game. You have to actually set up your performance criteria. Like I said, milliseconds, that's a response time. Then if it fails, then you know you need to do optimization. But if it's still okay, then you're happy with that. Don't try to over-optimize that. The other thing is the benchmark the environment. Anytime when you do your performance test, you have to make sure you run it in the same production environment. Like for example, today when I'm running those tests, I show you the data. It may not be the same data I run when I go home, because getting Robert's suggestion, I'm running a screen capture on my machine. So it's going to share the CPU time, right? So every time when you do all the tests, always make sure you're running it in the same production environment. That way you could get your that data more accurately. Okay, so it's a high five kind of game. Let me actually show you the game. So this is it's a website, web application, and then I'm using some jQuery, and it's everything is in this very simple JavaScript file. I think it's about 300 lines code or 400 lines code. Okay, and then let me actually run this game. And I'm using IE as example. The version I'm running is Windows 8.1 IE 11, but basically you could run it in any browsers as your choice. Okay, so it's a high five, right? Turn off the music. You get a little sick after you test it for so many times. Okay, so this is basically a very simple game. 2 type of players, right? They're doing this. They rotate for 4 directions, 4 sets of directions. Every time when they hit, they make a high five. And the scores is basically based on that hit, right? So if you click on any of the player, that player is going to rotate. and hit all the surrounding players, and causing the surrounding players to generate another list to hit, right? And obviously, the higher score, the better, right? So when I'm looking into this, and one of the performance meter I put is frames per second. So when you measure performance, frames per second, how many of you never heard about frames per second? Good. So FPS is a very good indication to see how response your app is. And then the way I did it for this particular, let me actually sort of set up. Because I want to take some performance data, but when I do all those click or hit, I wouldn't be able to repeat my test sequence. So hence, I need to set up some not exactly random kind of sequence. I purposely put some sequence there so that I could test the benchmark and I could take the data, right? So let's actually run it again, right? So you see the FPS has something like a 20, 30, and then I have a little high five with different scores, right? The record is 5,000, right? So let it run for a little bit. What I want to show you is, I want to actually share with you, let me actually hold on to this. Let me actually go to my slide, tell you the game, nature of the game a little bit better so that you will understand. Okay, so let me actually first talk about this before I go to the what tool I could measure. Okay, so very simple games, right? So basically what I have is a matrix of players, right? Depends on your matrix size. You could start with something maybe 8 by 8 up to like a 26 by 26, right? Different matrix. Each player has 4 set of directions, right? Do this, and backwards. You touch one player, it will generate a list of neighbors to rotate. So that's the part of the game, to rotate. To rotate, they could actually hit the 5, big 5, right? And then you will actually go through that list, because that list will causing the other part of the list to go. So it's an iterative kind of loop, right? So until they finish empty this all the neighbors, until this list is empty. So what are the things, what are the objects, or what are the techniques we use in this game? A few things. We use arrays a lot. We use objects, and we also use objects with different properties because we have to define the different directions, right? We use a bunch of numbers. We probably need to do some math in order to do that. And we use some animation loops because everybody is doing a little animation, right? And in other words, we do quite heavy memory allocations. Even though it is a pretty casual, simple game, but still, if you look at all the objects on the matrix, right? Okay, so what we're going to do is I'm actually going to go through this slide first. So I'm actually using 2 kind of testing tools. One is a new feature in IE 11 called UI responsiveness tool. That particular tool will actually measure the duration for different stage of that particular, what we call the browser pipeline. And they use color coding to show for different stage. And then they will show you in the demo. And you basically catch up the frames per second. And among that, you will see all the different color coding representing different things like a loading time. In this case, we don't have loading time, it's a website. Scripting time, garbage collection, the time spent for the starting, for the rendering, and so on. And then you could also take a look at how, what's the total duration for each of those. And you could zoom it into a particular thing. It's a profiling tool, right? So that's one of the UI responsiveness tool I'm using. So I could get a basic picture about how responsive that particular app is. The other part, if you want to do a little fine detail, we recommend is using Windows Performance Toolkit. It will give you a lot more information in terms of garbage collection, the thread output, the CPU, and so on. So why the CPU is so important? Any guess? I guess it's a very generic question. CPU is always important. But why it's important for the modern apps? You have tablets, you have a phone. CPU is directly related to your battery life. So in other words, I don't know the implementation for the other major browsers, but if you look into IE, look into Windows, if in that tablet, the machine mode, if it's a power save mode versus a full power mode versus a battery kind of mode, you will see very different data from frames per second. So this is actually a tip for you if you want to test your user's kind of like a scenario. You do want to look into that. And the CPU is a good indication to see relate to your battery life, right? So this is actually a good tool, performance, Windows Performance Toolkit to sort of look into that. Okay, so I will briefly just go over some of the pipeline. I think most of the major browsers using that as a same concept. So use IE as an example. So normally when you run any of the script engine, JavaScript engine, underneath that, it's always going through a networking stage. It will go through a parser stage so that it will actually create a DOM tree for you from the website. It does take a DOM data creation with all the capability is a pretty expensive step. And then it will do the formatting, it will set up a layout, it will calculate the position of each of the pixel, calculate the relative size, relative width onto the browser, and so on. And then they will create another what we call display visual tree. This is a final tree which relate to painting and the rendering stage. So finally it will actually be represented and rendered onto the browser. So basically for any of the browsers, they go through this, right? So when you talk about performance, we do have different data to represent for different stage so that you know where you are, right? Okay, so let's actually go back to our demo. Okay, so what I'm going to do is I'm going to actually start with F12 tools. And you know F12 tools, just like any of the browser kind of debugging tool, they have different kinds of feature for DOM Explorer, for checking the console, to do the debugger, debug your JavaScript, HTML, networking is like a fiddler kind of thing. You could check the networking profile, into that. And then you could also do in the memory profiler to see how is the memory doing in this particular app, right? And obviously, this is a part is kind of like the for not just the website, but also tell you what kind of browser profile you're using, the desktop or some other things, the layout. And what I want to introduce you more is this new tool called UI responsiveness. And I could actually just take a look. Let me move it a little smarter. Wait until let's take some profiling data. I want to make sure it's sort of 0, and then we start to take some data. Okay, so now we start the profiling, right? And then this particular one is running the benchmark, and then I could leave it run for a few times, right, until I get enough statistics, right? And now I could stop it. And then this UI responsiveness tool is basically measuring the frames per second, right? You see it from that little scale, but let's see. So now you see a pretty complex spectrum, right? You have different color. For example, the things you probably want to pay attention is your scripting time. This is a little orange color, red color here. Garbage collection, does it happen too often? The styling and the rendering is always different color. Now, what kind of drives me more attention is those little dip. This particular one is measured frames per second. 60 frames per second is a perfect score, right? It's like the biggest, like the highest, like a human eyes. The human eyes, the frequency is 60 hertz. So 60 frames per second is your eyes could handle. So if we could get a straight things response, everything's 60 frames per second, perfect. I don't need to be here to talk. My game is perfect, right? But what usually you will see quite a bit of data, like 20, 30, things like that. And for example, if I'm interested in a particular, say I'm interested in this particular scripting, and I'm interested to see what's going on with that garbage collection, I could basically do a little zooming. And it will zoom into a large scale. And you could even take a look what exactly for a very small scale. And within that, you could actually take a look what's the duration time, right? Like for example, we use 60 frames per second as a guideline. So if you 1 divided by 60 frames per second, we're talking about 16 milliseconds, right? That's actually the responsive time you're looking at. So for anything which is go beyond, obviously 16 milliseconds is a little kind of too strict, it's hard to beat. But if you look into the data, if it does go beyond quite a bit than 16 milliseconds, then you know there's something you probably need to look into, like this. Just take 1 milliseconds. This garbage collection takes 1995 milliseconds. So one thing, like sort of first catch my attention with the code is I see a lot of garbage collection going on. And then if you think about 16 milliseconds, your garbage collection already takes 1995 milliseconds. You know it's going to be pretty slow. You're not going to beat the good data, right? So because of that, so I use the performance data, the Windows Performance Analyzer to take a look at the detail of those garbage collection, because you don't want to see too many garbage collection going on. So let's actually continue from there. So this is the first run data I get from my code, right? And it does seem like there's quite a bit of garbage collection going on. So my first principle is the memory usage, stay link, right? So stay link is always important. So how many of you never heard about a garbage collection? Okay, I guess I did. Oh, okay. So garbage collection is something you will see that, let's start from the Java time, right? Garbage collection is always there, because when you allocate something into the memory, when the allocated memory is full, right? Every engine, JavaScript engine or Java virtual machine, all engine has different default size, right? When it's full, it's going to do some what they call reclaim or clean up, right? But the garbage collection is also very mysterious. The reason is you cannot enforce garbage collection. You don't know when garbage collection is going to happen. Even though you enforce it, the system is not going to listen to you. They will have their own way, algorithm to do that. So when we say garbage collection is bad, is because that particular memory allocation pool is already full. Because it's full, they have to clean up. And do you know every pause, every cleanup would take milliseconds to do that. So meaning if you create a lot of objects and then maybe unnecessary allocation, you're going to cause garbage collection to happen a lot. Hence, it's going to have a lot of pause in your game or in your app, right? This is not something you want, right? So first thing is, let's look into to see how we could actually fix it. So I'm looking into my game. This is the JavaScript level I'm looking into, and let me actually first look into some of the, let me actually use new. New is actually a very universal object creation way. So when you look into your code, you probably will check how many new things you allocated in your code. I have something to create an array, to create a players, that looks pretty okay. Create an array based on the board size, right, the matrix size, that looks fine. And I also have some, that doesn't count, it has to be a new, right? So let's go down a little bit. So I also have some matrix creation, which is in this case is I'm using a 4-dimensional array to create a matrix, use the object pool, and then creating every single one of them with the 4 different properties and the dimension to represent that particular player. So that's what I do, right? All right, so that looks okay. And then I'm also using what we call object pool to fill in, initialize this matrix, right? So it represents 4 different directions: north, east, west, south, and use the binary kind of like a 1, 0 to represent different direction, right? Is it good? All right. Okay, so that looks okay. And then let's actually look into a little bit of like the rotation and commit thing. Okay, so when I click on any of the players, it's going to do rotate. So when I do rotate, it do what? 90 degrees kind of rotation, right? So in my first implementation, what I do is I checking the different direction for, like, for example, both north, east. Then once I figure out that direction, and then say what I'm going to do, right? And then there's some other directions, so on. So 4 different directions to check. And then I'm actually basically, implementing those things by initialize data, by introduce more directions like east-south, southwest, and west-north and northeast, right? 4 different sort of like properties into it. And then this is all new position, right? And then after I rotate, then I generate a list, and causing the neighbor to commit that rotation. So I'm doing things again, try to fill in the checking if it's facing northeast, then this is what I would do, and if it's facing different direction, and this is a new node. So I'm creating a bunch of new nodes when I'm causing that rotate to happen, all right? So obviously when we're talking about you see so many news in an app, it's probably not a good idea, right? You probably kind of sort of guessed what I'm going to do next. So do you think it's a good idea? I introduced 4 different like extra direction, northeast, southwest, all those things. Do I have to do that? Okay, do I have to do, because I need to causing them to rotate, I need to create a new object just because of that? Do I need to do that?
No.
Probably not, right? The way I ask is probably not. Okay, so this is, this. So what I want to do is, let's actually go to rotate fast. So I fixed the algorithm a little bit. What I'm saying is, I'm not going to introduce all those new direction, northeast, all those things. Because I could just simply represent, if it's northeast, then I know it's either north and south. The other direction has to be east. I don't have to create anything like called northeast. Because once you have north-south, the direction is always fixed. It's always east, right? So I'm actually using this, still using north, south, east, west to represent the property instead of introduce new one. That's the first step I did. And the second step I did is, with a node, I create a lot of new node. Okay. When I create all the nodes, remember in the old way, I actually created a bunch of new nodes. But here, actually, I don't have to do that because I already initialized all the nodes with the right direction. All I have to do is to leverage all the object pool, all the objects in that, and fit in the same, and reuse the same object again, instead of creating all the new rotated object direction. Get it? So this is the 2 things I did for my previous method and new method. Questions? All right. Okay, so let's actually fix it, right? Go back. So here, I'm going to call the method with a new commit method, rotate. All right. And save this method. And one important thing is obvious to see if this performance state is this app is still running. Because a lot of times you try to fix something, but you break it, right? Let's take a look. Okay, looks like the game is still show up. And then I look at that. I look at the data. I think I see a little bit of improvement in terms of getting little high scale, but I do still see some like a 20, 30, all those things. Okay, so I fixed something, but I know it's not a complete fix yet, right? Okay, so let's go back to see what kind of performance gain we really get from there. So, so we do some detailed measurement by removing all the new objects, by eliminating creating unnecessary objects. I could reduce the garbage collection time to 1/3. Hence, in another word, you improve the JavaScript performance by 3 times, right? So that's a pretty easy fix for you to do anytime you look into your object new creation. So best practice for staying lean is avoid unnecessary object creation. That's always the #1 thing. Use object pool whenever it's possible. The other things to think about is, how many of you use closure a lot? Event closure? Yeah, closure is very helpful. It could be very powerful. However, sometimes if you rely on too much on the closure to do event handling, it could slow down your performance, simply because all the closure is still tied up within the memory. The memory has to do all the cleanup for itself, because you never say you need to clean up that, right? So for you, you could purposely, you may want to do that. Try not to do a lot of dynamic creation for the DOM tree, because DOM tree is always very, very expensive, right? That's something you need to keep in mind. Do not do implicit object allocation, like a bunch of new, like what I did, right? This is always good. So these are a few tips for you to stay lean. And then the thing to watch out is your garbage collection. Okay, second thing is about a fast object type and creation. Now, I know like a lot of people think they know object creation, they know how to assign property very well. But let me show you this example. Okay, so I have a variable. I have a different two property called north and south. I'm assigning different variables into these properties, right? So what I have is I have a north equal to 1, south equal to 0. So every time when you're assigning those things in the JavaScript engine, they have to allocate different object type for you. So this is how it goes, exactly in terms of the engine, in terms of the memory. Now let's look at another object called P2. And then in this one, I also have two properties with the same value. However, I have something called south first and north. So it does look like the same properties has been assigned to that variable and with the same data. How many of you think these two object types are the same? One think it's the same. How about the rest of you? Yes or no? Yes, you think the same? Unfortunately, these are not the same. So what does that tell you? Every time when you assign in properties, the property order matters. You think it doesn't matter, well, just assign it, but it doesn't matter. You're creating two different object types with P1 and P2, even though they're exactly, in terms of content, they're exactly the same, isn't it? All right, so that's the first tip to share with you. The other tip to share with you is, I actually made this mistake myself a lot. When I'm doing this, like assigning all the created object, I try to use some if statement, check the condition. What you may not know is you think it's safe to do all the checking and then assign the variable into the property. But what you may not know is every time you use any of the condition, you create a P1 and a P2 like this. The object type are very different, two different object type. So you end up with creating a lot of different new object types without noticing. The good way to do that is do not use the if statement if you can. Just assigning a property like that. Then when you actually initiate the P1, P2, these are the same object type. So this will be faster because it saves the memory, it's less object. This will create a lot of unnecessary objects. Good? Okay, this is actually, how many of you use prototype in JavaScript? A lot, right? So you just have to be careful. Whenever you do the all those the default property signing up, use a prototype, the keyword. Then all the variables like P1, P2, P3 you created later, their object type are totally different. Because the prototype is a different way to assigning the default properties. So when you do that, you're creating a lot of different object type. A better way to do that is actually not use prototype, just assigning the property directly to that particular, say, player, and initialize it. Then all your P1, P2, P3, those are same object type. All right, so this is another thing. When you're doing the initialization and property signing up for your prototype, make sure you don't do this. Right? Okay, so this is obviously some people probably know already. Whenever you do a little property bags like this, right? Anytime you do a little property bag like a P1 and P2, things like that, they are never the same object type. They are very different object types when you try to use slow property bags. So if you don't want to use property bags, don't use them. They could be slow because they create a lot of new objects, which is not something you want or intend to create. How many of you like to use delete? Okay, that's good. Delete is not your friend. Delete will cause operation very, very slow. If you want, simply just assigning something equal to 0 or undefined, then that's totally fine. Do not use delete operation. It's slow, all right? Because it involves the property, the type of conversion, all those things. The other things to watch out is in the constructor depends on your property list. Like for example, if you try to do 256 over 100 properties, if you look at that, obviously common sense tells you it's not going to be fast, right? It is true, it's slow. You don't want to do things like that. You need to use maybe an array or something, or do you need to use an array like this? So normally, you should just keep it as concrete side as possible. Don't want to assign any too much property. This is pretty interesting. So we actually had some sort of debate even in the team. How many of you actually tried ECMA 5 or 6? It's actually a good way to do JavaScript programming. In that, actually, they introduce more things like a get, set, enumerable. How many of you use it? It's actually, if you're from object-oriented like a Java or some other object-oriented programming background, this is very natural for you to use, right? It's very maintainable, readable. It's a good programming style to sort of look into. However, if your object is going to use it many, many times, it will slow down your performance if you using all the get, set, enumerable kind of way to do things, which is sort of like complying with ECMA 5 and 6. It will. If you only do like a couple of them, it's okay. But like mine, right, I'm doing big matrix. It's going to run a lot of times. So simply just do some very primitive way, right, assigning, initializer with all the different property, very simple, just keep it like this. This will be a lot faster. How much faster? Let's take a look. Okay, so let's go back to the code again. And very simple. This is a very simple way to do. So the first version, what I do is I'm trying to use get, set, enumerable to create that player. And then I optimize it because it doesn't really work too well. Then I actually just make it very, very simple to initialize with all the variable like a north, east, like this one, like we see before, right? North, east, south, west, like this. All right. So I'm going to change the code a little bit. So this is going to use a faster player. And then this is, remember there's only 2 players, one is Judy, one is Mia, right? So we're going to actually, all right? So make it all the faster creation. Okay. Save it, give it another try. All right, same thing, running a benchmark, and try to generate something. So I think I see some good data, and I still see something in the 20 range, right? But I see something in the 30 and the 40 range as well. Okay, so let's see how much actually by using different constructor in terms of the true performance saving. So this is another set of results from the performance data. So the JavaScript execution by changing all the different player in this particular case is from 3.8 seconds to 2.2 seconds. So in other words, I saved the JavaScript execution time by 30%. So which is give you another improvement for the performance by 30%. So that's really not that bad, right? Just by changing this particular object creation to do that. And obviously your mileage might be different. Okay, so in summary, what I did here is create and use the fast data type. Keep the shape, keep the order of your object consistent. Avoid the type of mismatch for different types. So all those tips should be able to help you to make your performance quite a bit faster. So that's the second. Third principle is, am I going too fast or it's okay? Yeah, okay. Third thing is fast math. Now this is something maybe review for you guys. We all know JavaScript, working with numbers is very flexible. All numbers are IEEE 64-bit floating point kind of numbers. They're flexible, however, it could be challenging performance-wise. Why is that? So everybody heard about stack and heap, right? Understand the difference? Very good. Okay, so when we look into those data, if you have an integer kind of type, right, most likely you're working with 31 bits. And then your integer type data is going to allocate it on your stack. Because stack could only hold up to 32 bits. And it's fast access. And when your particular object type is not a non-integer, you may look into floating point, a string, or some other things, then it will go beyond 32 bits. So what it will do is it will have to move from the heap move from the stack into the heap, because heap is larger, right? The length is longer, but the access is slower. So what does that tell you? We have integer, we have different data type, which will have different allocation on different things. So what does that tell you is, if you have any of those data, right? So if you have things like the representation, what we have here is, if it's an integer, then it will probably more likely leave on the stack to do any manipulation. But if it's a heap, if it's a bigger, it's like a string, if it's a floating point, or hex number, then it's bigger than 32 bits. It has to leave it onto the heap. So for different kind of data type, you have different stack and heap to work with. So if you look into this example, it's doing a mass, right? And then it's also doing in a way that you could choose to work with different data type. You could choose to use integer, you could choose to use floating point. So this is a question for you. For your particular app, if you think your app is good enough to do with the integer, by all means, just use integer. Don't want to go into the floating points. I know that people just say, it's so easy, just like doing math, I'm going to do a plus b divided by 2. But you're creating a floating points here. You're manipulating floating points. Hence, everything will be slower because it has to do the manipulation allocation onto the heap. Whereas if you could make it rounded up into an integer, then everything will still keep on the stack. So it will be quite a bit faster, right? So that's actually a tip for you to think about in your app, how you want to address that. Same thing, I know that if you're from object-oriented programming background, you do things a lot of times you just say, I have a method to calculate the distance between P1 and P2. I just have one method that represents everything. But perhaps you have to think about some other options. This, if you do one method, then it doesn't matter. You're saying I could have an integer, x, y could be integer or floating points. So you're just doing one method and doing all the calculation. But because the compiler doesn't know if it's an integer or floating point, so more likely they leave everything onto the heap. So it will be slower to access heap. So maybe one of the smart ways to do that is you could separate these two methods into two different types. One is called distance floating, basically work with floating point. One is called distance int. So by separating these two methods with different data type, the compiler will be able to figure out, this particular method only needs integer, so I could leave it on stack. And when you talk about distance float, then they say, it has to move on to the floating point position, then have to leave it onto the heap. Get it? So you could actually separate these two methods in order to work smartly. So good practice for you is use 31-bit integer math manipulation whenever possible. Avoid floating point if they are not needed, right? And basically that's the sort of the tips for you, floating point and integer you have to think about. A related thing to that issue is the arrays. We use array a lot. How many of you never use array? Okay. So we use array a lot, and we know it pretty well. So what you may not know is when you use array, when you do initialization, you are creating a lot of those what we call object type in the engine. For example, your first element is 1, and then it's going to be a 2.3, the floating point. It's going to be a string, sorry. So it's going to actually allocating all those different type progressively when you go through this list, all right? So you keep in mind, so one thing to think about is if you have an array, if you have some idea about the size, you don't want to do it in an empty kind of allocation. You want a compiler to know approximately I need to allocate 100 elements into that array. That way it will be faster. Because otherwise compiler will have to do it incremental way because they have no idea. They will give some, depends on the engine implementation, they will give some default size, and when they go, need more, they will allocate more. So basically if you know the size or have a guess of the size, put it there. It will be a little faster. The other thing is, you probably should do something like what we call a hint. You should always initialize something, because that way compiler will know what kind of data type they're working with. Otherwise, it will have to guess, probably allocate the most memory for you because it doesn't know what's content inside that array, right? So this will be a little slower this would be faster. So just give a little hint. If it's a string, if it's an integer, if it's a floating point, give something there, right? That would be faster. And then the other things to look into is, this is sort of new. So for the modern JavaScript engine, there are actually a difference between a floating point array versus an integer kind of array, right? There is one called a float64 array. There's one called int32 array. So when you do everything just lump sum into array, you're not taking advantage of the JavaScript engine because you could do better job. Like here, you basically just say, put whatever data I want, integer, floating, string, whatever, right? But here, you're taking advantage of those new types, right? So for the floating, you work with a floating array. For the 32-bit integer, you work with integers. So you do have a choice to make your app runs quite a bit fast by taking advantage of the new feature in the JavaScript engine. Now, perhaps the next thing you probably say, hey, JavaScript engine is supposed to be more smart nowadays. Wouldn't the compiler figure out if I'm working with integer array or floating array? Yes or no? Yes, modern like a JavaScript engine is a lot smarter than before. All the optimization has been applied to that. All the major browsers are doing it, right? So, but the thing is, in your coding, you have to sort of like help it to happen, right? So, for example, when you do this kind of array assignment, sometimes people just say, I just do a mixed array, dump a bunch of stuff there, right? I don't care, let the compiler to figure out. That way the compiler will never be able to do the quick estimate to say if this array is integer or floating. Perhaps a better way is you separate these two arrays. One is integer, one is floating. That way when the compiler looks into that, say, I know A is an integer array, B is a floating array. Then I know which integer type or floating type array I want to apply. So this way would be a lot easier to help modern JavaScript engine to run faster because you're taking advantage. Right? Any questions? This is kind of brand new, right? It's again a new concept, right? All right. Okay, so again, I guess delete is not a good thing to use. Try not to use delete in your array. It's very slow operation. You could simply just assign to a 0 or undefined to have the same result. This is pretty, I think we've been talking about this many times. However, if you look into your code, somehow you always make that mistake. That is, into a big loop, for loop or whatever, you always putting something called a.length. Do you know every time in order to go through this loop, if it's running 1 million times, that a.length is going to be computed 1 million times. So what would be a better way? We talk about that. Everybody knows that. When I point out that this might be the problem, you immediately notice, right? So what a better way is obviously cache that particular, do a calculation, right? Cache that length, and then put it into a loop, right? That way will save you a lot of the way to do the memory allocation, all those things. Very simple, right? But it's $1 million tip for you. You check your code. I bet you will do something like this. Okay, so a few things, best practice for summary. Pre-allocate all the arrays. Keep array type consistent, right? If it's integer, integer. If it's string, string. If it's floating, floating. Use the typed array, floating or integer, whenever possible, because you're taking advantage of modern JavaScript engine, right? It will be faster. And enumerate arrays efficiently. This is also another tip for you. Sounds good? Okay. Do less. The fifth principle is about do less work. Everybody loves to do that. But actually in your code, sometimes you're not doing it. This is actually 2 lines of code I got it from one of my app. Not proud to show you that, but actually that's what I did. So what I'm doing here is I'm doing a lot of, for each of rotation or loop, I'm doing a bunch of document, body, game, get and by ID, the class list, do this, remove the class, add a class. I'm doing this. When I did that, I didn't really realize this particular 2 statements will be running so many times. And do you know how expensive it is every time you run this operation? Every single one of them, document, dot body. Every time you're putting those things into it, it will create a new DOM. It will append a DOM. Do you know how slow it is? It's very, very slow, right? So you have to be careful. So a better way to do that is you just assigning that particular one into an element. You do it right in the front, and then into the loop, into the for loop or whatever, you just use them like this. Element.remove, element.add. It's also for readability. It's more clean now, right? So this will be actually will help you a lot with the DOM parsing as well as processing the JavaScript. Right? Anybody make a mistake like this? Yeah, I know. Well, it's just so natural, when you do this code. Okay, so yeah, so this is another tip I think some of you already know. That is when you try to say everything on the get element by ID, whenever you get, is basically a string, right? But a lot of times in this case is, say, for example, I'm working with a board size, right? So this is integer, right? But when you do this, you're not realizing when you do this board size, you're basically converting your string every time into integer, again, right? So what would be a better way to do is parse that integer, create that board size right in the front, because it's a string, right? Everything is string, right? And parse that integer, and then that board size. And then you could use it in your loop, it doesn't matter how big it is. Do not underestimate that. Just by doing that alone, based on one of the benchmark, you save 25% of marshalling cost reduction for the init function. So that's a pretty major things, right? So it's when I show this code, everybody says, hey, this is stupid. Why are we doing this again, right? Why don't I just parse it? So a lot of times, go back to your code, take a look. Are you doing this? Are you parsing it correctly? Are you actually cache the data correctly? Right? Okay, so another one is about a request animation frame. I know that a lot of you probably know that already pretty clear. But sometimes you still use like a set timeout, set interview. You do something like 0. What does that 0 mean? When you try to do some animation, put a second parameter 0. That means doing as many as possible. That means there's no interval or whatever to set up. A correct way to doing that is, like I said, 60 frames per second. Human eye 60 hertz. So you calculate that. This is 16 milliseconds. So basically all you have to do is 16 milliseconds. That's all you need to do. Your animation interval should be just 16 milliseconds. That's it. Don't do anything more than that, because your eyes are not going to see it. Nobody's going to appreciate that. In other words, right? So try to remember that, right? Okay, so let's see if we could have more to fix. So if I go back to the code, I think you probably remember I said I create a bunch of benchmark. I purposely try to control the sequence, right? And then set up the right sequence so I could take the data. But is that something you want to do in real life? Probably not, right? You don't need to actually run the benchmark, make sure all the high five happening in the same sequence. You don't want to actually purposely creating a node at a particular point to do that. In real life, you don't do that. But in performance tests, you need to do that. So I just do a very quick fix here. I actually just comment out my benchmark data, and then I'm just leave it to use a random generator for all the matrix and all the rotation, right? That's what I do. Okay, so let's see if it will help. Okay, so we do see some improvement. Whoa, we see something that goes even 60. We also see some dropping like a 60, 40. So we do see quite a bit of improvement in terms of when we're fixing those random generator. But what I do see is something I don't like is why I go beyond like 100 or something like that. Right? That doesn't make any sense. We don't need such a frames per second. We're wasting some resource there. Okay. So this is actually the second thing I need to fix, which is do not leave the animate 0 means as many as you want. But leave it just take the request animation frame, that's actually a default value, and then by default it's 16 milliseconds. Take advantage of that. Okay, let's see if it's better. Okay, so I see more consistent 40 and 50 kind of range, right? Is it better? It looks like it's more stable now, right? So if you take some performance data and you will see the UI responsiveness will be more flat. You don't see a major dip or things like that, right? Does that help? Better? Okay, so cool. Okay, so obviously there will be little warm up. You will still see some little, at the beginning because it's just any engine needs a warm up kind of time. All right. So this is pretty cool. So I'm going to wrap up pretty soon so that you could actually ask me questions. So this is the last fix, right? So by doing this frames per second kind of fix with animation, like to do instead of 0, I do the 60 milliseconds. I actually, reduce the 75% performance into 65%. And this is your CPU time. And like I said, this is actually directly related to your battery life. So by having less CPU usage, your battery life will be longer. So this is a very good tip for anybody working with apps running on phones or tablets, right? Okay, so this is the final result. Obviously, we still have a little dip, but it's more you could see the performance data is more smooth, right? And then onto that. And then if you want to code, this is actually where you get a code. You could actually take a look at code onto that URL.